In this video, we're going to look at atoms. So let's start off with a simple atom like carbon. What does a carbon atom actually look like? Well, in the center of our carbon atom, we have a mixture of positively charged particles that we refer to as protons and neutral particles that we refer to as neutrons. And together, these form our nucleus. And the nucleus is at the center of our atom, and it's where a lot of our mass comes from for our atom. Now, surrounding our nucleus are these negatively charged particles that we refer to as electrons. So in the atom of carbon, we have 6 protons, 6 neutrons, and 6 electrons. Now, how can we figure out the number of protons and electrons for other atoms? Well, in order for us to do that, we should probably head to the periodic table. And so as we see here, it is structured by increasing atomic number. So if we have a look at carbon, we see that the atomic number of carbon is equal to 6. And from what we've just seen is that that is also the exact same number of protons and electrons. So if we know the atomic number of our atom from the periodic table, we can work out its number of protons and electrons. Now you're probably thinking, but what about the number of neutrons? How are we going to figure that out? Well, that one's a little more difficult. If we take 100 atoms of carbon, 99 of them are going to have 6 neutrons. But one of those 100 is going to have 7 neutrons. So it's not always going to be the same. And that's where we have what we call isotopes, where we have the same number of protons, the same number of electrons. The only thing that is different is our number of neutrons. And for carbon, we can actually have 3 isotopes. And we call them carbon-12, which is our main one, carbon-13, which has 7 neutrons, and carbon-14, which has 8. Another term you might have heard is ions. Well, ions are slightly different. Let's have a look at sodium. So sodium, in its elemental form, has 11 protons, 12 neutrons, and 11 electrons. But if we change the number of electrons and we remove one, we're going to have 10 electrons, which means we have one more proton than we have electrons. So we have a positively charged ion there. If we have a look at chlorine, chlorine from our periodic table has 17 protons, it has 18 neutrons and 17 electrons. Now in this case, we could add an electron to chlorine and end up with 18 electrons. And if we have a positive and negatively charged ion, well, they are going to be attracted to one another. And we can have what we call ionic compounds forming between these two ions. So using the example of sodium and chlorine, when these two ions come together, we refer to them as ionic compounds because we have an attraction between a positive and negatively charged ion. Now, a positively charged ion is referred to as a cation. So to help you remember that, you might want to think about a happy cat. And the negatively charged ion in an ionic compound is an anion or an angry ant. Now, this ant may not look so angry, but he's having to work on a Sunday, and you wouldn't be too happy about that either. And we can name this ionic compound sodium chloride. Now, we can have a whole range of different cations and anions, which means we can have a whole range of ionic compounds. So some examples of cations are things like magnesium ion. We can have cations that are the same type of atom, just different charges, so iron 2 plus and iron 3 plus, and we can have complex ions like ammonium. We can also have different anions here. So we have simple ones like oxide, O2 minus. We can have hydroxide, which is OH minus. We can have more complex ones like CO3 2 minus, or our carbonate ion, and sulfate SO4 2 minus. We notice that the charge of our ion is always in the top right-hand corner. And any combination of a cation and an anion can give us an ionic compound. So in this case, we have magnesium hydroxide. And we're going to talk about how ionic compounds are formed in our next video and how to